All right, I have here some fake sample data of the Kinetics and Clorox lab, and I'm going to walk you through all the steps that you need for your data analysis. The first thing is that we had the spectrophotometer measure percent transmittance, but we need percent absorbance. So I'm going to make a column here for percent absorbance. And the equation that it gives you in the lab handout is that absorbance is 2 minus the log of transmittance. So instead of doing 20 plus calculations here, we're going to use the spreadsheet to help us. And the way you set this up is you select the first box here under percent absorbance, and then you type equals the number 2 minus or subtract, type in log log, and computer here is going to prompt you to take the log of some number. So you'll put your parentheses, and instead of typing in the number that you want here, the number 50, you're just going to click on that box. So 2 minus the log of the value that's in cell B2, close those parentheses, and hit enter. Your first percent absorbance is 0.260. Now, instead of even having to type that again for all your other values, you're going to select absorbance, that cell you just filled in. Grab or highlight the corner here and drag all the way down, and it automatically will fill in all of your absorbance values here. So you see if we click on the second cell, it's equal to 2 minus the log of cell B3, value 60. The next one is equal to 2 minus the log of cell B4, that's value 65, and so on. So now we have time and percent absorbance. We know that we're also going to want to make graphs of log of absorbance and 1 over absorbance. So we're going to make columns for that as well. We'll label these here. This is natural log of absorbance. And we're also going to need 1 divided by absorbance. Again, we're going to use the spreadsheet to help us, so we'll highlight the first cell of natural log, and then I'm going to type equals ln natural log, open parentheses, then select my first absorbance value, and close parentheses, enter. And this gives me the natural log of my first absorbance at time 0, and if I highlight the corner here, drag these values down, now it automatically populates the cells with all of the natural log values. I'm going to do the same thing here for 1 over absorbance. Highlight the first cell, type equals 1 / divided by, and then select my first cell, percent absorbance. So that's 1 divided by absorbance, and again, drag this all the way down. And the computer automatically calculates 1 divided by my absorbance value for all of those rows. Now that I have that, I'm going to start inserting my data tables. So I'm going to select a random blank cell here, hit insert, I want a chart, and currently there's no data selected, but I'm going to have my chart editor open here. We want a scatter plot, and I'm going to drag this off to the side just so that we can still see our data values. Resize things a little bit here. Drag that up so that we can see everything. And 3 dots, here's my chart editor. Got a scatter chart. We want on the x-axis our time value, so I'm going to click Add X-axis and then highlight my data here, time 0 through 180. And then for my y-axis, I want percent absorbance. So I'm going to highlight this whole column, including the header. Select OK. And there we have my plot. Now, of course, being good scientists, we want to label our data. So I'm going to go to Customize and drop down Chart and Axis Titles. First, I'm going to type in my chart title here, and we'll say absorbance versus time. And we also want to give our axis labels. So under type here, I'm going to select first my horizontal axis, and that is time in seconds. And then I also want to label my vertical axis, which is my percent absorbance, which is unitless, so we just leave it like that. And there is my absorbance versus time graph. Now we want to know which of our three plots is going to be most linear. So I'm going to scroll down here to Series and select this option for trend line. And we want to display it, so you label, use equation. And there it gives me the equation for my trend line. We also want the R² value, so we check that box there. And there we have our absorbance versus time graph. Going to do that again for the other two plots. So select a cell, insert a chart, I'm going to delete this chart because it's already populating with a bunch of stuff I don't want. There we go. There's a nice blank chart. Move it off to the side here. Resize things a bit. And start adding data. So on the x-axis, we still want time. Okay. And then we want to add a series of y-axis values. Scroll up here. This time we're going to do natural log of absorbance. So highlight this whole column, hit OK, and make sure that we have it set as a scatter plot. There we go. So this is our natural log data. Going to go over to Customize and give us some titles, chart and axis titles. Chart, this one will be natural log of absorbance versus time. Horizontal axis is time in seconds, and the vertical axis is natural log of absorbance. Again, that's a unitless value. Then to get our trend line, we scroll down to Series, scroll down and select that we do want a trend line, linear, display the label with the equation, and show the R² value. We see this graph has an R² value of 0.95, which is quite a bit higher than the previous one. And lastly, to make sure that we don't have second order equation, we're going to plot this last graph. Select a blank cell, insert chart. This is going to be a scatter plot chart. Get this out of our way here. There we go. Add an x-axis. This is time. Add a series y value. And this time we're plotting 1 over absorbance. Okay. And now we're customizing. Titles. Chart title. 1 over absorbance versus time. Horizontal axis, time in seconds. Vertical axis, 1 over absorbance, which is unitless. And then to get that trend line series, click trend line, label, use equation, and show R squared. Now I'm going to close out my chart editor so we can compare these graphs. My first graph had an R squared value of 0.81, so it's kind of linear, but not as good as the second one, which had 0.95. But this third one had an R squared value of 0.99. That means that this is the most linear graph. So 1 over absorbance corresponds to a second order equation, which tells me that my sample data is second order overall.